In the vast expanse of our universe, there are phenomena that defy explanation, massive structures that challenge our understanding of physics, mysterious objects that move in ways they shouldn't, and entire regions of space that seem to break the fundamental laws of reality. These aren't science fiction plots or theoretical concepts. These are real, documented mysteries that astronomers and physicists still struggle to comprehend. How were they formed? What forces created them? And perhaps the most unsettling question of all, what else might be lurking in the depths of space, waiting to be discovered? From black holes that are impossibly massive to galaxies that move as if guided by an invisible hand, today we're exploring some of the strangest unsolved mysteries of our cosmos. So sit back, relax, grab a snack, and let's dive into these cosmic enigmas where our understanding of the universe itself seems to fall apart. The Great Attractor is one of those cosmic mysteries that seems to defy explanation. Hidden behind the plane of our Milky Way galaxy, this gravitational anomaly is pulling on thousands of galaxies, including our own, with unimaginable force. Like a massive cosmic magnet, it's drawing everything in our region of space toward a single point, at speeds of millions of miles per hour. But the most puzzling part, we can't see what's causing it. First, major mystery, the Great Attractor. The Great Attractor sits in what astronomers call the zone of avoidance, an area of space obscured from our view by the dense center of our own galaxy. It's as if something is hiding behind a cosmic curtain, influencing everything around it, while remaining concealed from direct observation. What makes this mystery truly perplexing is the sheer scale involved. The gravitational pull of the Great Attractor affects an area of space spanning more than 250 million light-years, tugging on approximately 100,000 galaxies. That's hundreds of thousands of star systems, each containing billions of stars, all being pulled toward a single point that we cannot directly observe. Theories about what the Great Attractor might be range from conventional to controversial. The mainstream belief is that it's a massive concentration of dark matter, that invisible substance that makes up roughly 27% of our universe. Astronomers suggest that an unusually dense region of dark matter could create enough gravitational force to pull galaxies toward it. But there's a problem with this explanation. The gravitational effects we observe seem too powerful even for a dark matter supercluster. Some calculations suggest that the Great Attractor would need to have a mass equivalent to tens of thousands of galaxies, a concentration difficult to explain with our current understanding of how matter distributes itself across the universe. That's why some researchers believe the Great Attractor might represent something fundamentally new, perhaps an exotic form of matter or energy we haven't yet discovered, or even a flaw in our understanding of gravitational physics itself. Second major mystery: fast radio bursts. But the Great Attractor isn't the only mystery that forces us to rethink what we know about the cosmos. Space is filled with unexplained phenomena, signals and events that challenge our understanding of physics. And next, we explore one of the most baffling discoveries of the 21st century: fast radio bursts, cosmic flashes that pack the energy of millions of suns into mere milliseconds. Before we dive into the next mystery, just a quick note. While the visuals in this video will provide extra context, they aren't necessary to enjoy these stories. Feel free to let this play in the background while you work, relax, or even fall asleep to these eerie unsolved mysteries. And if you'd like to support me making these videos and get access to exclusive stories and all of our videos ad-free, consider becoming a Patreon member. The link is in the comments below. Now, back to the stories. Fast radio bursts, or FRBs, are among the most enigmatic phenomena in modern astronomy. First discovered in 2007, when astronomers were reviewing archival data from Australia's Parkes Radio Telescope, these intense flashes of radio waves last for just a few milliseconds, but release more energy than our Sun produces in decades. What makes FRBs so mysterious is not just their incredible power, but their apparent randomness. They come from all directions in the sky, from sources billions of light years away, with no discernible pattern. Some occur just once, never to be detected again, while others, called repeaters, flash repeatedly from the same location. The brevity of these bursts makes them especially difficult to study. By the time astronomers detect one and point their telescopes in the right direction, the burst is long gone, leaving behind only questions. What could possibly generate such tremendous energy in such a short time span? Theories about the origins of FRBs range from the mundane to the mind-bending. Some astronomers believe they could be caused by neutron stars, the ultra-dense remnants of massive stars that have gone supernova. When neutron stars with incredibly powerful magnetic fields, called magnetars, undergo starquakes, or magnetic reconnection events, they might release the kind of energy we observe in FRBs. But this explanation has its problems. The regularity of some repeating FRBs doesn't match what we'd expect from random stellar events. And the sheer diversity of FRB properties suggests that they might have multiple causes rather than a single explanation. That's why some researchers have proposed more exotic origins. Perhaps FRBs are the result of cosmic strings, theoretical defects in the fabric of space-time left over from the early universe. When these strings interact or snap, they could release bursts of energy detectable as radio waves.